Okay, so ladies and gentlemen, the language C. C is a special place in my heart. I have a love-hate relationship with C. The best articulation of that came from someone whose education overlaps a lot with mine, but he was a decade or two earlier, Guy Lewis Steele, who's one of the inventors of Java. And he has a lot of language preferences similar to my own. And he described C as one of his favorite languages, but he said it was his favorite in the same sense. So he lacked the Canadian vocabulary that I'm going to use. He talked about his beater truck. So his old banged up pickup truck. And C is his old banged up pickup truck. It's when you need a job done, it's there, and you can do it with kind of a minimal of fuss if it's a small job, and just get the job done. It ain't that pretty, but it's straightforward and reliable. And I kind of feel that about C. There are aspects of C that, as a compiler writer and someone interested in performance and large-scale system implementation, they give me the willies. C has a loosey-goosey type system that will allow you to declare something that's secretly, an array to an array of structures that contain certain elements. You can treat it, if you want, as an array of doubles, or as a pointer. You can go in and play tricks about the underlying type system because C lets you do what's called casting one type to the other. Type coercion is another rule for it. You can take any type, cast it to a void star, which is a bizarre notion, and then you can cast it to anything else. So you give me a set of integers, I can give you back something that's a set of doubles, and no one can stop me, and the compiler can't stop me. So the fact that I, as a programmer, tell the compiler that this points to a double, the compiler has to take that on faith. And sometimes this is useful. You want to read something in from a file, you read it in, and then you can treat it however you darn well please. And you happen to know the file structure is like this, and you just say, treat it like this, and it says, okay. And it may march off that cliff with that in mind. C is a wonderful language. C is a neat language. C is not my language of choice for creating large-scale, robust systems that converge in time with sophisticated algorithms and that are performant in today's era. C is a language that's close to the metal, and people get caught up in that. Oh, it's compiled C. But what really counts these days, by and large, ladies and gentlemen, for larger scale performance-heavy systems is parallelization, low memory footprint, ability to make use of different levels of parallelism and levels of the memory hierarchy, cleverness in the high-level algorithms. And C is going to get in the way of some of those things because you get involved in the minutiae of memory allocation, and compilers can't figure out squat about what depends on what in C, because you have all these pointers going around and you can't tell what can be modified by what, etc. And it's a compiler writer's nightmare in terms of providing guarantees. And that really limits compiler optimizations, and that really limits, in turn, the ability of compilers to parallelize automatically and to extract performance gains. And it's overstated in terms of its performance. People talk about it sometimes as if it's going to be a factor of 10 from optimized Java code. And we'll be examining that claim critically with empirical data shortly. Okay? But C is a language close to my heart. I love it. I love it. Just like I love parts of assembly language. But C is better than that. C is finer, made of finer stuff than that, but it's got its its issues. And one of the issues that students run into from a learning perspective is the fact that the type system can be cryptic. So let's take a look at something here as a type, okay? Here we go. A char. So what is this? So here we have a char star arg v like this. What is this thing? What is this thing called arg v?
A pointer to an array of characters.
Sorry? Pointer to of an array of arguments. Okay, so it's command line arguments. Okay, so I'd like to help you. Anyone else want to say something? Yeah?
Is this a pointer to an array or an array of pointers?
Okay, so this is exactly the confusion I want to address. The way to read this and see, there's one beautiful rule that was articulated to me almost 30 years ago, within the month probably of this. I guess you folks weren't talking about C then, weren't you? You were learning your ABCs maybe at best. Maybe you weren't even doing that. Ladies and gentlemen, the rule for this is very simple. If you have something like this, this is a declaration, and it's saying if you have this thing, okay, and you take and you index into it. So you read this as if it's a variable. Say, okay, I'm going to index into it. I'm going to look inside. I'm going to put an index here. I will get something which, if I then apply a star operator, if I then dereference it, as we say, we look inside it, we apply a star, we treat that as a pointer, it will give us a character. Okay? So the way to read it is you actually simulate in your head this as these are operations being performed on this thing, and they will give you back the final type. Okay? So if I have this thing and I take its index by doing argv 2, for example, I will get back something that when I put a star in front of it will give me a character. Now, the thing that's a little bit ambiguous you got to watch out for, and it came out in some of the comments, is which is greater precedent here? Is it this or is it this? Right? And in fact, it is the first of those. So it is this guy here. Okay? But that's how you read things for types in C. You think of it in the way it's declared. It's as if I were applying these operations around it, I will finally get out that type. So it tells you the steps you need to go through to get the final type. Okay? So let's apply this rule to a few of the types in here. And then I will apply this rule to pointers to functions. Okay? Because the syntax there can be hairy. Okay, so let's go take a look at this. So we're going to go down to, let's start with one that's very straightforward. This int star current cells. What is that? Current cells. What is that?
Integer pointer.
It's a pointer to an int. It's something which when I apply a star to it in front of it, I will get out an int, right? So it's a pointer to an int. Straightforward idea. You see them a lot. Int stars, they're often called. Okay, great. What is this thing? So int double star.
Is it a pointer to an int pointer?
Yeah, it's a pointer to an int pointer. So this thing, whatever it is, if I apply a star to it, so I dereference it, so it's got to be a pointer. And then I further take a star of that, so that's got to be a pointer. It gives me back an int. So it's a pointer to a pointer to an int. Now in C, that could also be a what? Pointer to array of ints. because an array event, if you refer to the variable for it, it's a pointer to this allocated block of memory. Okay. And so this is a pointer to an int. Does that make sense? Okay, let's sort of poke around and see if there's any more puzzling ones here. Okay, yeah, here's int argv, here's int c, okay, argc. Here's a pointer to a char, right? It's a thing which, if we apply a star to it, we get back a char, so it's a pointer to a char. It could be a string, right? Because strings are just pointers to chars. Okay. Okay, so shouldn't be anything too confusing here. Now let's talk about pointers to functions. So pointers to functions are great, but they are a pale cipher compared to the true beauty of first-class closures, as we will see in the fullness of time, because that is your destiny. Okay? So, ladies and gentlemen, a pointer to a function is something that refers to one function or a different function. Okay, we could have one implementation of, and we will, one implementation of this rule. Where's this rule? This rule, right? Oh, where is it? This rule, there it is. There it is, compute liveness. Okay, compute liveness here. We could have, compute liveness for, so compute liveness classic, right? And that's going to take in these things here, and it's going to be exactly this implementation, da-da-da-da. And there could be a compute liveness, relaxed or something, I don't know, that has the same arguments. This is important. It has the same signature, as we'll say. Takes the same type of things in, as arguments, and returns the same type of thing. It has same type of argument, same type of return value, and that's all C cares about. And that has a relaxed version of that rule. Maybe it allows account surrounding cells to be between 2 and 5, or something like that, instead of 2 and 3. Eh? And a pointer to a function will allow us to sort of say, I want to use that one, or I want to use this one. It's going to refer to maybe one of those, or one of 10 different possible ones. It's going to allow us at runtime to determine which of them we're going to use. And we're going to be able to call it, and it will need this information to do its job, Boolean, and integer, and it will return a value that indicates whether or not it's live. Certainly that should probably return a Boolean. Anyway, the point is, this pointer to the function will allow us to dynamically choose which of these we're going to call. Does that make sense? For example, it would allow the user at runtime on the command line to say, use this one, use that one. And we're going to call the right one appropriately. Or maybe we read in from a database and we choose we're going to use this one or that one under the circumstance. Pointers to functions are beautiful things. Pointers to functions are great things. Pointers to functions are dangerous things. Why are they dangerous?
Because they're void star.
We can get them from void star. That's right. Void star is kind of like the Death Star. Okay, that's a strange analogy, but it raises great risk. Because you can, if you can cast anything to a void star, if you can cast one thing to another, you could treat something that's actually, a cosine lookup table and treat it as a pointer to the function to direct into it. You could have the code jump into that place, and you can. I think you folks probably have experienced bus errors, seg faults.
No, never.
better man than I. That's great. I encountered all sorts of bus errors. I'm not even talking about trying to get to school. So yeah, no. Ladies and gentlemen, and see, you can have all sorts of whacked out stuff happening. But that's just kind of part and parcel of that language, right? After all, you can have pointers that are loose pointers that can be pointing to who knows where, and you can write into them, and it can let you write into the stack and overwrite your return pointer, and then you're off in la la land when it tries to return from the function. All sorts of weird and wonderful things and not so wonderful things can happen in C. Yeah.
So I have a question.
Yeah.
In this case, at least, we could simply do the same thing by using variables, just parameterize the liveness conditions, correct?
Correct. In general, you would need to maintain to do that additional information, right? And you would need to do that in general, you might need to maintain voluminous extra information, where sometimes really what we want to specify is we want to specify the rule in a more abstract way. Maybe this is one way in which they can vary, but we may want to, if we needed to do that, we'd need to specify sort of enough about the rule as data to fully pin it down, and sometimes that's quite extensive. Often we want to abstract away the rule. So the way in which we do this, yes, go on.
I was just wondering, and then how does this differ from, in functional programming languages, partially applying recurring functions?
It differs dramatically in terms of several different things. At a high level, it has some similarities. The biggest difference is, and this, I'm going to unpack this statement for you in future lectures. This is not something that I was going to do today. The biggest difference is that it's not a closure. It has no information bound up with the function. So the function doesn't have the information it needs to do its job packaged with it. Okay, and that limits its applicability. Okay, so ladies and gentlemen, how would I create a pointer to this function? What I do is I would create here something that is going to point to this sort of function. It's going to point to functions which take two arguments like this and return one in the following way. A pointer to a function like that would be associated with a type such that if I had it and I applied a dereference operator, this is a pointer to a function. Apply a dereference operator, I get back a function in the sense that I could then apply it to a bool, and I could apply it to an int, and I would get back what? An int. This is the type of the pointer to the function. And I can take a pointer to a function as an argument to another function. Basically telling a function to which I pass it, hey, call this function when you compute that thing, or call this other function. So this could be an argument, just like I could pass an int, I could pass a pointer to a function. And that's how you declare it. Does that make sense? So we could say with this pointer to the function, if we had this in our code, this is a declaration of this variable. This is a variable. And if we went and we said, pointer to the function equals compute liveness, then this will be pointing to that function. If we said instead it was, a compute liveness classic, it would be pointing to that function. And we could then call it, right? We could say pointer to the function, and how do we call it? We do this. Call it like that, and we'll pass it, false and 3, and it will return what? 1. And it'll return. It will evaluate this thing. It'll say, this is false. This is 3. Is it alive? No. Okay, else we're going to check if this thing is 3. Yes, it is, so it's going to return 1. It's going to return true. So that's how we call it. Does that make sense?
I didn't really get it. And we denote the pointers, the star pointer in the pointer function. So can you draw the relationship between this function with the pointer function?
Between this guy? So what I'm saying is that this is one function, and often in our code, we want the ability for our code to choose at runtime which function to call. We have maybe different functions that are variants of this. One is a classic version. One is a relaxed version that has a more relaxed criteria here. And we want to choose at runtime based on what the user requests, or when the user clicks this button or that button. We want to have it choose which function to call. And so we want here, Jen, we want to have a way of sort of saying, I point to some function that matches this general signature. It takes a Boolean, it takes an int, it returns an int. I want some way of saying what I have in this variable is a reference to some function. And to hide the details, whether it's a reference to that particular version of the function or another one which has a different rule, I want to be able to have this. Sometimes it'll be referring to that one, sometimes to that one, depending on what the user does, what the user specified in the command line, or what have you. So in order to do that, I have a pointer to a function. And sometimes it's going to point to that one, sometimes to that one. Just like a pointer to an array would sometimes point to this array or that array. Okay? It would be determined at, as we say, at runtime. If the user says, I want to run it with a classic rule, this pointer to the function will point to the classic one. If the user says in the command line, I want to use my great rule, it'll point to this one. Okay? So in order to have that flexibility, we don't want to hard code our code around the fact we're calling the classic rule, because that might not be true. The user might want us to call this other rule. They might want it to call the great rule, or might want it to call the Nate rule. So we want to give that flexibility at runtime. So the way in which we do that is, in order to have our code be flexible, be nimble, so that it can sometimes call this one, sometimes call this other one, we put in place a pointer to a function. This pointer to the function will sometimes refer to one function or another, just like a pointer to an array sometimes can refer to this array or that array. Does that make sense? And when we have that pointer function, this is how we declare it. Just like we had a pointer to an array, we could declare it in a certain way, as an int double star or what have you. We could point here to a function in this sort of way. And given that pointer, we can then assign things to it. Here we're assigning it a pointer to this function. Or we could call it with particular arguments to tell it, hey, call this guy. Am I addressing your question? Okay, how many people are feeling kind of confident about this idea? Okay. So a pointer to a function allows us to choose at runtime which function code is going to call by allowing us to pick at runtime which pointer to use, which function to use. Yeah. So
ampersand in front of compute liveness classic.
Do I need it, you're saying?
No, I was.
Is that what it is?
Is that
It's
what
an
it
amp.
is?
Yeah.
Okay.
It's a poor rendition. It's a poor attempt on my part to render an ampersand. Okay, Yeah, I'm. My penmanship was judged substandard, and it's never recovered. Somehow I didn't get the lesson on ampersands when I was in school, and I somehow learned. Somehow those neurons have never learned to fire. So that's an ampersand. I need to spend like a morning drawing ampersands, and I'll get it finally. Okay, other questions? Fortunately, I've probably typed in my life, I don't know, 10,000 ampersands, but I've never had to write it out. Yeah.
If we want to choose the specific function as the user asks, I think we can use switch case.
Yeah, you can. You can. So the way to do that, so flexibility can be achieved in a number of different ways. And you're right that there will be a switch case you're going to want to allow them to specify on the command line, like this versus that. You could do it with a switch case. And in fact, you could encode in a number which you then on which you switch. You could say, they want function 2, right? I'm going to call this one. They want function 3. I'm going to call that one. If you do that, that will be viable. It would work. It will become increasingly cumbersome as the number of possibilities goes up, because you're going to have to hard code in the program, the mapping from number to the underlying function, and it gets awkward to do that because you need this big switch statement. Instead, here, what we're basically doing is we are treating which function to call as a piece of data. Okay? And we could put it in, I'll be with you just a sec, Chris. We could put that in a lookup table. We could put it in a hash table, for example, which maps requests by the user, the name from the command line, to the function to use for that. And we don't have to deal with this kind of separate encoding of it as an integer or as a, as some other way of encoding it. Instead, we just say, okay, if the user requested this function, this is the pointer to the function to use, this one, this one, this one, this one. And it's a little bit more straightforward than needing to maintain this extra information and call off to a big switch statement. So pointers to functions could be, if we had no pointers to the functions in the world, civilization would not collapse. Things would continue, and people use languages where there aren't the equivalents to pointers to the functions, but it becomes awkward and it becomes cumbersome to as the number of possibilities grow. And in general, when we're dealing with situations where programs load themselves at runtime, for example, they load their code in at runtime, often the functions are bound at runtime. We say, okay, we want to point for this case to this one, in this other case we're pointing to that one. And we actually don't have the option of knowing when we're writing the program which all the possible functions are. Sometimes, these days particularly, the choice of what is loaded will be different for different runs, and when we're writing the program, we don't know all the possibilities that we'll obtain when we're actually running it later, okay? And there, pointers to the functions will be needed because they will enumerate a set of possibilities that we don't know when we write the program. Chris?
I was going to offer a counterexample for the switch case statement,
Yeah.
Which is if you were writing some sort of list library,
Yep.
and if you're writing a library, for instance, and you were writing a filter function,
Yeah, sure.
you would need to take a predicate which you don't know,
ahead of time.
Yeah.
And it's related to my point there, but I like it even more. In general, we're seeking our code to be run by many parties that have different needs and different libraries that they're using that we don't have access to. if we're writing code for our own use, maybe we know the 3 possible functions we could use. But if we're writing code that's part of a library that could be used by anyone around the world, they may want to adapt, they might want to use our library with their own functions that don't exist at the time we produce our library. They're functions they create 2 years from now, after we've shipped our library. And this is a reality, right? The folks who created the Java standard library or the C standard library, that's being used by tens of millions of people around the world without knowledge on the part of the people who created it as to exactly how it will be used. And sometimes people do want to use our code with a much larger set of possible arguments, possibilities than we can anticipate when we write our code. And so providing a way for them to specify any old function to our code, and this is what Chris was getting at, is very, very handy because it allows them to adapt it to their needs. So I like that a great deal, Chris. And it harks to some of the points we'll be making with subtyping and subclassing, because there too, ladies and gentlemen, you are creating a class which might be subtyped by someone, subclassed, for example, by someone 2 years from now using subclasses you never get to see, and you want your code to work reliably and robustly with their subtype that they have written, that you haven't had a chance to inspect. Similar thing with pointers to functions. We'd like them to be able to specify how to use our code with their own functions that we don't have access to right now. And we'll see that a lot with first-class functions. Okay? Pointers to functions are a big part of flexibility in C at a larger level. In operating systems, I would expect it to be quite large, particularly modular operating systems where you want to be able to have things attached at runtime or what have you. You have drivers that get rolled out after the operating system has been deployed, which weren't anticipated, and you want to be able to call off to things in these drivers. Okay, ladies and gentlemen, pointers to functions will be part of the Thursday assignment. Okay? Great. We're going to see how pointers to the functions, while useful, while pragmatic, while widespread in large code bases, will be a pale cipher compared to what we'll do with true first-class functions. Okay? Okay, the final thing I want to say here, and I just want to check the time, make sure I have time to say it. We have 2 minutes left. I want to show you one final element that we'll